Welcome back to Math 104. We found that if we flip a fair coin 8 times, the probability of exactly half heads, half tails, in other words 4 heads, 4 tails, equals 70 over 256. That's approximately 0.2734. To answer the same question about flipping a fair coin 10 times, that is, obtaining 5 heads and 5 tails, we need to do some expanding of Pascal's triangle, at least enough to get us down to this number right here. We need to compute 10 choose 5 to find out how many outcomes there are in the event that we're talking about. It's worth noting that in order to find this number, we didn't need to expand all of row 10 or even all of row 9. We could take row 8, which we had already found, and then find just enough of row 9, namely these two entries, in order to find ultimately the entry in row 10 that we're looking for. So we could have gotten away with much less work than is displayed here. Really just this information right here. Thus there are 252 distinct outcomes in the experiment of flipping 10 times, in which there are 5 heads and 5 tails. Out of 1,024 distinct possible outcomes total, that is only about 0.2461, which is less than what we got for 8 flips. Some students find this surprising. They find it surprising that it's harder to obtain exactly half heads, half tails on a greater number of flips. Didn't we say at the beginning of the course that the more times you flip the coin, the closer the relative frequency of heads tends to get to 0.5? Aren't we a little bit closer to the long run after 10 flips than after 8 flips? If you thought that, that was actually a very reasonable thing to think. The reason it doesn't quite work out is that the relative frequency of heads after many flips tends to get very close to 0.5, but it's not obligated to land exactly on 0.5 on the nose.